So I've mentioned before that Avogadro's number is a terrible number. And so I stand by that because basically what happened is you take some volume of material and you measure how many particles are in that, and that number is Avogadro's number. The problem with that is that measurement is fucking hard. So even up until 1971, Avogadro's number was defined officially as 6.02 times 10 to the 23rd power, or basically 602 quintillion. And the difference from that we don't know. We don't care about. We don't know it at that point. That's bad, right? We landed on the moon by this point, but we couldn't measure this value to more than 2 decimal point. Yeah, it's more than 3 significant figures. That's horrendous, right? This number is an absolute disaster. Objectively so. But it actually gets worse, because the way that it was meddled with actually makes it even worse than this. Right, so like my idea, I've mentioned this before, my proposal is that if you're going to be using such a number like this, if this is having a number that refers to quantity of molecules in this regard, you should just fucking define it. And you should, in your seek to find a number worth using as your definition, you should just go out and find a number with lots of convenient factors and lots of roots. My current favorite is 60 to the power of 12, right? Because 60 has, well, you can take all of it, you can divide it by 1, you can divide it in half, you can divide it by 3, you can divide it by 4, you can divide it by 5, you can divide it by 6. 7 doesn't work, but 7 doesn't work with almost anything. 8 is cooperative, it doesn't work perfectly. 9 is also cooperative, and 8 and 9 will both show up in pretty much any power of 60, right? Once you square 60, 8 and 9 now go into it. Because you had, 4 goes into 60, so once you get another 60 on there, once you do 60 times 60, well, you get 4 times 4 happening. So 8 is in there, and 3 goes into 60, so when you get another 60 on there, 3 times 3 is happening. That takes care of your 8 and 9. So once you've squared 60, 8 and 9 are handled perfectly. 10 goes into 60. 11, it's going to be some of these weird prime numbers that we really don't like in base 10 anyway, that are going to be the biggest problems. So, 11, 13, 12 goes perfectly. 14, because of the 7, you're going to have issues with that. You're always going to have holes, no matter what your number choice is. You're always going to have gaps. So, you kind of have to make compromises in order to get 60 big enough to fit 7. We're going to have to multiply 60 by 7, and we're at 420 by now, and that's a relatively large number. 60 is relatively small. It gets along nicely with base 10, base 20. It cooperates with things we already have and we're already familiar with, so it's kind of nice in that regard. And then, 15 goes into it, 30, 20, the gaps between them start getting bigger from that point, but it's got a lot of factors. And then 60 to the 12th has a lot of roots, right? Because 12 is like 60, very similar to 60, is divisible by 1. Everything is divisible by 1. Except fractions. Anyway, you can cut it in half. So, because it's a power, that means it's a square. You can cut it by 3, which means because it's a power, right? 12 is our exponent. It's also a perfect cube. It's also a perfect tesseract. Right, we miss 5, we get 6. It's not really helping us at this point because, I mean, it might. I don't know. If you ever need the sixth root of something. 60 to the 12th has a nice sixth root. Yeah. So I think, like, if you're going to spend hundreds of years trying to find such a number, maybe you should just stop, take a breath, and say, oh my fucking god, I've been retarded for generations upon generations. Let's just define a number in a nice way. And a number we know its value, and we know its qualities. And we specifically chose both of those so that it works for us. But that's not what happened with Avogadro's number. And worse, it's kind of messy. The history of all of this is messy. But there was, I'm not sure if originally is correct, but there was a point in time where a gram, the mass, 1 gram, which also at this time was the fundamental mass unit of the metric system. It no longer is. Now the fundamental unit is the kilogram. Anyway, the gram was defined as the amount of water that will fit within 1 cubic centimeter at a given temperature. I don't give a fuck about the temperature, so whatever. It's a normal temperature, like room temperature kind of temperature. It's a normal temperature. The detail, I don't care about the digits on that. It's 20 something, I think. Anyway, yeah. Comfortable room temperature. How many water molecules will fit in 1 cubic centimeter? So, if that's what a gram is, and Avogadro's number is the number that correlates grams to Daltons, right? So if you have 1 mole of a substance, then the number of grams that you have should be exactly the same as the Daltons, the molecular mass, the weight of 1 molecule of this substance. Then Avogadro's number should be a perfect cube because we defined the gram as a perfect cube of a material. So it should work out that way. It should be a perfect cube. And the current definition, the 2017 definition of Avogadro's number, is astoundingly close to a perfect cube. Its cube root is between 1/20th and 1/25th of being a whole number. It's off by 1/20th of a particle out of it. So this number is 84,400,000. Where the hell is it? 446,884.958 or something. That third digit, I'm not entirely sure. It's a higher digit. So it would round to 84,446,884.96. That's what it would round to. Out of the 84.5 million, 1/20th of a particle is fuck all. So really, Avogadro's number should just be, we just round that up to the next, because the whole point of Avogadro's number is we know that matter is quantized. So Avogadro's number should be an integer. So just round it up to the next integer. Take the ceiling. So it's 84,446,885 cubed. That's what Avogadro's number should be. And at the point in 2017 when Avogadro's number was defined and they were like, oh, fuck it, we can't measure this thing, it's too goddamn complicated, we're just going to cut it off. At that point where they cut it off, that was the only possible number that it could be as a perfect cube. Because the last 2 digits of precision, right, so we've got the 2017 definition is, Jesus Christ, where is it? 6.022140076 times 10 to the power of 23. So that level of precision is absurd. That's really high precision. But in order to preserve that final 7/6, the only possible cube is the cube of 84,446,885. Because if you take 84,446,884 and cube it, then your last 2 digits turn into like 55. And if you take 84,446,886 and cube it, then it turns into something like 88, or something like that. It's both digits, both of those final digits, that 7/6, change. But if you keep it 85, if you keep the final digit 5, then that level of precision that we had up to 2017, that was defined into the system, is preserved. And really what should have been going on all along is somebody should have been like, hey, we're looking for a cube. The number we're looking for is going to be a perfect cube. So here's our candidates. And as time goes by, you just narrow the list until you get it down to one candidate. And then you're like, oh, well, that's it. That's Avogadro's number. That's what should have happened. This is not what happened. What they did is they just said, oh, the only method they ever applied to finding it was measurement. Nobody stopped to think about it at all. They're just like, oh, this is what we do. We measure for this number. And they got to a point where they're like, fuck trying to measure this thing. Because it's impossible. What is my phone doing? Jesus Christ. Stop. So, yeah, it's like nobody paused and was like, hey, we're looking for a perfect cube. Why don't we just compose a list of the possible perfect cubes and then kind of work our way towards one of those? If they had done that, then, oh yeah, so it gets worse. Because Avogadro's number was just cut off. They're like, yeah, this is what it is. Right? This is as much precision as we're able to measure. Fuck it. Let's call it at this point and just define it as this. Because of that, it broke the connection between Avogadro's number and the Dalton. It broke the entire original purpose of Avogadro's number to correlate the number of grams in a substance to the molecular weight of the substance. That entire goal has now been broken by a tiny degree, of course, but it has been broken. And if they had simply paused and recognized, hey, we're looking for a cube number here, and we have reached a level of precision where there's only one candidate, so it shouldn't be 6.022140076 times 10 to the 23rd. It should actually be exactly, right? And because we know that our cube ends in a 5, it's going to end in a 5. We know this. It's going to be exactly, I'm not going to use scientific notation here, 602 sextillion, 214 quintillion, 76 quadrillion, 888, where am I at? Trillion, 919 billion, 328 million, 204,120, exactly 5. It should be that number. And no other number. No other number makes sense. And this is knowable. This is knowable at the point where it was cut off and they're like, no, fuck it, we can't figure out what this number is. It was completely possible to figure out what the number should be. And if you take that number, then yeah, you're still going to get some deviance from the Daltons because that correlation wasn't necessarily going ever to align with the fact that matter is quantized. But it's going to preserve the correlation better, and you now have a number that is Avogadro's number, which is the closest possible quantized number, discrete number, that it could possibly be. That makes sense. It's a perfect cube. You know, it does all of the work that it needs to do. And the fact that this was completely not even close to the path that was taken, but all it takes to recognize that this is the path that should have been taken is, you know, pausing for half a second and saying, oh, fuck, we're doing this wrong. All it took was somebody to admit, hey, we're never going to measure this number, but we could actually think this through a little bit. all it would have taken was that. The fact that that never happened, and all of the entire scientific industry was just so dead set on measuring it, and measuring it is the only way. And this is how we do it. This is what we've done for generations. And this is, by God, this is the only way we're ever going to find this number. Or we have to just, at some point, give up. Just accept it. Yeah, that kind of stubborn pigheadedness. Fuck off, science. Fuck off. You made it worse with that bullshit. As that bullshit normally does. That sort of attitude typically makes things worse, and it did here.